So for our day 3 notes, what we are working on is we are working on graphing our exponential functions, which you have done this before. So this is hopefully going to be a little bit of a review for you. So we're going to graph here y equals 3 to the x power. So if you don't remember how to do that in your calculator, we're going to go to the y equals. We're going to type in 3. Then you're going to push the little caret button to get you up in the exponent. And then you're going to put your x in there. So then if we take a look at our table, we got to fill in our values. So for -2, we got 0.1 repeating. And then we got 0.3 repeating, 1, 3, and 9. So we're going to go ahead and plot those points over here. I always like to do my whole numbers first and then go through and get my decimals. So what you have to remember with your exponentials is they're going to approach your x-axis, but it's never going to actually touch or cross your x-axis. So we just kind of extend our line a little bit and then we put a little arrow there. So let's go through and analyze this. First we have to know, is it a function? And our answer for this would be yes. It would pass our vertical line test. If I were to draw a vertical line anywhere on here, it would pass it. Our domain for this would be x is an element of the reals. It's going to keep going on forever and eventually use every x value possible. Our range, again, as we said, it will never touch or cross your x-axis. So it's going to be everything higher than that. So our range for this would be that y is greater than 0. It's not going to be equal to 0. It's purely going to be greater than 0. So since it never actually touches or crosses the x-axis, we don't have any x-intercepts. Now you got to be careful. You don't want to say 0 because then you're saying when x is 0 is an x-intercept, but it's not. So we have to say none. There aren't any x-intercepts. Our y-intercept is at 1. For symmetry, it wants to know if it's even or odd. Even or odd. So remember, even is symmetric over the y-axis. Odd is symmetric through the origin. This one is neither, so symmetry would be neither. Next, they want to know where is the graph increasing. So again, if I follow my graph from the left and I'm following it, my pen is always going up, so it's always increasing. So we say x is an element of the reals. For every single x value, it is increasing. Where is the graph decreasing? It's not. The graph is never decreasing. That graph is entirely an increasing graph. Our exponential, if it was decreasing, it would go this way and be opposite of what we have up there. That one is a decreasing. So they want to know, where is the graph less than 0? Remember, it's less than 0 if it's below your x-axis. This graph is not. So we can say nowhere. They want to next know, where is the graph greater than 0? So this would be above your x-axis. Well, if we take a look at it, the entire graph is above the x-axis. So we would say x is an element of the reals. The entire thing is above. They want to know where y is equal to a 0. And again, this would be a nowhere. Y being equal to 0 is on your x-axis. Our graph never touches our x-axis. So next they want us to find y when x equals -3. So I'm going to go to my calculator for this. Looking at my table, I'm going to go to where x is -3. One more. And I get 0.03704. 0.3704. That's what my y is equal to. Next, they want to know, for what x value is y equal to 243. So I'll go to where my y column says 243. There it is. My x is a 5. So x equals 5. 14, what is the absolute maximum value of the graph? Well, we got an arrow going up here. So this graph's going to continuously be increasing. So it'll never have an absolute maximum. Then they want to know absolute minimum. A graph's going to keep going down and down and down. You can't predict where the absolute minimum is going to be. So we're going to write none. Our asymptote, that's the imaginary line your graph keeps getting closer and closer to, but it never actually touches or crosses it, which would be this horizontal line right here where y equals 0. (17) is the inverse of this graph, a function. So remember, our inverse would be if we took our graph and reflected it over the line y equals x. Or, easier way to do it is take your points up here and just flip them. So 0.1, -2, 0.3, -1, 1, 0, 3, 1, 9, 2, there would be my inverse. So again, the question is asking, is that a function? Well, if I did the vertical line test, it would still pass it. So yes, that is a function. So assuming y equals f of x, as x approaches positive infinity, so that means the right side of our graph here, as we get approached the right side, our graph is going to keep going in which direction? It's going to keep going up. So as x approaches infinity, the f function also approaches positive infinity. As the graph approaches negative infinity, so that's our left side, our function is going to approach 0. Because remember, it's never going to actually touch or cross 0. And the name given to this graph, this is an exponential function. You got to remember by the shape of it that that's an exponential function. Let's take a look at our next page. We do have a natural exponential function. That is referred to as the letter e. So e is just a number that they have found naturally arises within our universe. It arises naturally in a variety of phenomena that plays a central role in mathematical descriptions of the universe. It is often used a lot in population kind of questions or situations and finance applications. So we'll be using it when we do some of our word problems in this unit. E is equivalent to approximately 2.718281828. So as I said, we have some mathematicians out there who sat there and they kept looking around at the various things within the universe and they kept finding this number coming up. So what they decided to do is they named it with the letter E. So we see E a lot throughout history, or throughout our universe. So to evaluate E, you do have a button on your calculator for this. So e to the -3. We're going to go to our blank screen here. Your E button is right above this button that says ln. So if you hit second and then ln, it gives you your e to an exponent. We want e to the -3. And there we go. So we're going to copy that decimal down. 0.049787068. So now I want you to go through for a minute, type in those other ones just to get the practice, and let's see what you get. So hopefully your numbers match up to mine when you typed them into your calculator. This, by the way, here is a 4. Doesn't really look 4-like, but it is. Next one, same thing. We're going to plug a 7 in for x because they told us to find f of 7. You got to make sure you remember to put in your exponent there that it's times a 7. 3.54 e to the 0.28 times 7 power. So when we type that in, we get 24.847644773. So that's evaluating with our e function. Pretty simple. It's nice that the calculator gives you that button to help you out with it. So next they want us to graph e to the x. So we're going to go back to our calculator, go into our y equals since we're graphing, and we're going to type in e, so second ln, to the x power. If we take a look at the graph, it looks exactly like an exponential function like we just did on the last page. So what I want you to do is take a moment, copy down your table of values, and draw your graph. So hopefully your graph matches mine. Your table might be a little different just because you picked different points than I did, but you should make sure your graph is the same up there. So again, taking a look, this is much like our exponential function. Our domain is still going to be XER. It can be so our range, once again, we have the asymptote right here where y equals 0. Our graph will get closer and closer to it, but will never actually touch or cross that. So our range is going to be y is greater than 0 because it's always going to be higher than that number. Our y-intercept is still a 1 because if you remember, anything to the 0 power, which is where our y-intercept would be, where x is 0, is going to be a 1. And then our horizontal asymptote, we just talked about that, would be at y equals 0. So is that e to the x? Exactly the same as our other exponential functions. And you can take that and move it around the graph. You can move it up, you can move it down, left, right, you can reflect it, just like everything else we've been doing. So let's take a look again with some more graphs. I want you to type these into your calculator. Get your table, which I already started making for you here, and I want you to graph them over on the left. So pause the video and do that. So as you can see here, what ended up happening with our graph of y equals 2 to the x is a reflection over the y-axis when we get our y equals 2 to the negative x. We talked about this with our transformations in the last unit. We have the negative in with the x, so it made it reflect over your y-axis. So a couple of other ways that they could write this, your 2 to the negative x, is they could take that negative portion of it and flip the 2 down below, and then it's a positive x at this point. They could also distribute the x to the 2 first and give you 1 over 2 to the x. So that's just a couple other ways you could see the same equation. These three things would all look exactly the same when you graphed it. So again, we talked about this. Here are characteristics of our exponential graphs. Again, I'm not going to go through it and read it through it. You guys can read through them yourselves. We've been through our transformations. So let's take a look at our last page here. So what I want you to do first, type this in your y1, type that in your y2, so we can take a look at them. For your 3 to the x, our domain is x is an element of the reals. Range is y is greater than 0. Y-intercept of 1. Horizontal asymptote at y equals 0. This is the graph we did on the very first page of our notes. So the difference between this graph and this graph, when you looked at it on your calculator, is it was down 4 units. They just took it and moved it down 4 units. So what happens when we move it down is your domain is still the same. Your range, however, now also gets moved down 4. And so instead of being y is greater than 0, we're going to have y is greater than negative 4. Our y-intercept also moves down 4, so 1 goes down to negative 3. And our horizontal asymptote, again, also moves down 4 from 0 to negative 4. So moving it down 4 makes everything move down 4. If we were to move it up, it would make all these numbers move up from our original parent functions. So what I want you to do now is go ahead and type this in your y1, this in your y2, pause the video so you can take a look at them. Again, since the negative was with the x, this was a reflection over your y-axis. And then another way we could write this is g of x equals 1 over 2 to the x. Just distribute that negative sign. Oh, I'm sorry. I wrote that wrong. Sorry guys, going quickly. Because it's negative, it flips it, and it's positive, so it would be y equal, or g of x equals 2 to the x. Okay, and our last one, since this is a basic exponential function, our domain is everything, our range is greater than 0, Y-intercept is 1, horizontal asymptote is y equals 0. Again, you can put that in your calculator. This time, the negative is all the way out in front. So it reflects over your x-axis this time. So you can take a look at it in your calculator. Go ahead and type that in. Our domain is x is an element of the reals. Since it reflected over the x-axis, everything changes. So instead of being greater than, it's going to be a less than. Our y-intercept is now a -1, but our horizontal asymptote is still at y equals 0. So if you're unsure about something, put it in your calculator, take a look at the graph. Let's see what it does that way. And then, as I said, all those transformation rules are exactly the same.